Welcome, everyone. So this is our intro on artificial intelligence in buildings and specifically HVAC practices. I'd like to introduce our presenter for this session, Doug Hampton. He is an optimization engineer for Trane. He's a licensed thermographer, also a very experienced commissioning agent. Uh, but Doug,
Well,
all you.
thanks, Robert. I appreciate you handing me off there, and Robert, I definitely appreciate you bringing me in with Best several years ago. It's been a great experience, and I really like what you're all up to. So, my name is Doug Hampton. I work for Trane and have for quite some time. I live in Omaha. I put a map there and what our current weather is today. Good morning, good afternoon, wherever you're at in the country. Today was the first time we've been above freezing, so it's kind of a heat wave going here. So I am going to attempt to talk about artificial intelligence in HVAC. It's a very wide process right now, and there's lots of different perspectives and opinions. So I'm going to try to give mine today. So let's get going here. Okay. So first off, I looked to see what AI actually thought of AI. And so I asked one of our generative AI tools that we have at Trane what AI is and what machine learning is. It gave me a few definitions, and I also had it create the large share of this presentation. And I did that to show some of the benefits and pros and cons of AI as we see it today. So as you see here, AI in regards to HVAC, optimizing energy consumption, reducing maintenance costs, improve indoor air quality, all these things you can get from really any search of what it is that AI can do or what we do. It explores various AI techniques that are being used in HVAC systems. What's the difference between AI and machine learning? And what you see here is you see three main topics and a considerable amount of redundancy. So what is AI? Does it write its own code? Is it an advanced search engine? Does it go out and find whatever it can find and not really knowing what the end result needs to be, what I want it to be? And there's another point that I'm making here as we go through these slides. You'll see a lot of slides that have text underlined. And in most all of these instances, that's because the AI, like any control system, is highly dependent on its end devices, sensors, etc., to make a decision based on that. So as we go through here, optimization is a key application of AI and HVAC systems. Using machine learning algorithms, we can analyze data from sensors and other sources. Feedback from those sensors is important, and AI cannot really determine real well if those sensors are accurate or not. They may be able to see some glide over time, but that's a discussion for another day. But we can use it to identify patterns and make predictions based on those patterns and to see what's coming based on the inputs that we have. This allows us to optimize energy consumption, reduce peak demand, and save costs. As you see here in this slide, there's a definition based on what my search, what the AI told me, the differences between AI and machine learning. AI is broad in a sense, and machine learning is a subset of AI. So by using the machine learning algorithms, we algorithm, and that's something we hear a lot about, whether it's doing analysis, fault detection, things like that. Anybody in the control world knows what an algorithm is. Let's say that basically most all of HVAC right now is reactive in nature, whether it's a critical zone reset, linear reset, any demand or dynamically based reset is reactive. We see something happen and we react. AI is more of a proactive approach, and I'm going to show you a few examples of that here today. So, how do I use it? Lots of people use whether it's chat or like I said, Trane has several tools that we use to develop prompts. We develop those prompts, we input the prompts, and we get information back. But again, it relies on those sensors, and I use it to basically sort through the noise of my day. And what would that be? Mass amounts of data. 20 years ago, a VAV might give us a few points, maybe a space temperature sensor, a space temperature set point, and some basic data logs. Now we're getting 15-minute interval data or 1-minute interval data as far as that goes, times 50 points per device, times 200 devices over a year's period, or even longer. And it's almost impossible for us humans to sort through this information. We end up spending all of our time digging through and processing the data when we really should be spending our time on the analysis portion of it. So I'm showing you a 3D image or model of interval data for an electric meter of a building. And just based on this model, and this is demand, you can see a lot of different things here. You can see when, based on the demand, you can see when the building is scheduled to start. You can see runtime in the evenings. You can see maybe when things probably shouldn't be running, just based on peaks and valleys and improvements or overrides. Are there overrides in place? But again, this is just reactive in nature. We can look back and say, does something happen this day? What exactly happened at that day? Now it's much more granular than our monthly utility bills that we all get. We spent more money this month than we did last month. Well, why? And this just gives us a more granular look at it. But instead of me spending hours and hours and hours developing, processing the data, I use AI, we use AI to develop the models so we can bypass a lot of that noise. So as far as predictive maintenance is another important, hugely important application of AI in HVAC systems. Now we do a lot, or we do a pretty good job, I should say, of trying to catch machines before they break, because nothing is more expensive than something you need right now. And when it comes to downtime, say in a factory, we want to be able to see that bearing or see that pump start to fail before it actually does. That way we can schedule maintenance proactively, whether it be a holiday or a scheduled downtime that we know is coming. If we combine this tech with vibration analysis and thermal imaging, we can really augment our predictive abilities. And nothing is more expensive than if you need it right now. So if we have the algorithms that can see over time, how is this pump or anything rotating really? Is it producing more heat? Is it vibrating more? This gives us an idea of when we can schedule that maintenance before it breaks. And again, we try to be as proactive as possible. We cannot predict the future, but we can sure take a look and try to be as proactive as we can. Now, as far as adaptive control, is a technique that uses AI to optimize the performance of HVAC systems in real time. Again, by analyzing sensor data. It's all about the sensor data. How accurate are the sensors? If I'm trying to control a 20,000 CFM air handler with a $5 discharge air sensor, it's probably not going to be as accurate as I would like it to be. So cheapest isn't always better, but we know that you get what you pay for. So by analyzing that sensor data and adjusting settings dynamically, we can achieve optimal comfort while minimizing energy consumption. And that's always where we want to go with energy consumption, is try to find that happy medium between reducing that energy consumption and comfort. I mean, if we really want to reduce energy, we can just go throw the breaker to the building, right? I mean, that'd be the best way to just not run anything, is the best way to conserve energy. So I asked our AI system to generate a series of charts based on a car analogy. You can see there on the top there, this is basically a car going up a hill with its cruise control on. And most of us drive, and we understand that when you leave the cruise control on, you see a hill coming, the car does not. So the second row there in the blue is throttle response based on what your cruise control is going to do to try to maintain your speed. And then the bottom one there is the speed of the vehicle. So if you see the reactive approach where the car is really, throttle's really doing nothing until it hits the hill and you get a sharp increase in throttle, your speed varies considerably, gets to the top of the hill, your speed drops, and then you start to speed up on the other side. If we could see the hill coming, we know the hill's coming, we can start our throttle response sooner and stay, let's say for a car, we'll stay in a lower gear. And we know that we can say, you can use your throttle within a specific speed set point as long as you maintain, let's just say 5 miles an hour. And it can do that and it can see it coming. So this is kind of an analogy to explain, are we really looking into the future? Not necessarily, but we can see what's coming if we have the data to do so. And in this case, the car analogy works out pretty good. Well, of course, it's all about data. It's all about historical data. As we're going up the hill, we kind of need to know what the car did the last time it went up a hill so we can determine the throttle response. And that's another part of AI is understanding the historical part of it, the historical data. Another big part of AI is fault detection and diagnostics. It's a technique that uses AI to identify and diagnose HVAC problems based on history. By analyzing again sensor data, can detect faults early and diagnose them accurately. This helps reduce downtime, extend equipment life, improve performance. And how is a machine performing compared to past history? Just because a machine is working, just because a space is comfortable, just like our house, just because it's comfortable does not mean that that piece of equipment is operating at its efficiency. So it gives us an opportunity to see that coming, and our efficiency is dropped. It's time for some service before it becomes an issue. This also helps us to prioritize service. I can think back when I was a service tech, let's say I had an 8-hour service contract with a customer. I'd show up, I'd get a list of issues from the customer. I would go fix those. And let's say I've got 4 hours left in my day that I owe that customer. I would sit down in front of the control system and look at overrides, look at alarms, and scroll through the system to see if I could see anything wrong. And back to being able to sort through the noise and bypass some of that. If the AI or even any analytic for that matter can sort out the low-hanging fruit, which things are not performing well, which set points are out of range, if you will. This allows me to give better value to the customer because I have those priorities and I can go directly to those. So what can we fix now as opposed to fixing or replacing later? Just because a machine's working well does not mean it's working its best. So occupancy sensing, we do a lot of things in the HVAC world using sensors, whether you walk into a hotel and the door sensor tells the point of sale, so there's somebody here, let's turn on the lights, let's adjust the thermostat accordingly. Again, it's based on occupancy. It's based on a sensor. It's reactive. Now, what if those occupancy sensors can give us pattern recognition? Analyzing occupancy data, we can adjust temperature, lighting, other settings, all still dependent on sensors for input. What if patterns can be recognized and systems can be brought on, more importantly, shut down proactively? What if a system could monitor occupant comfort or needs, in quotes, by monitoring sleep habits, heart rate, interior, exterior light levels, etc.? What if a system could change light levels and color temperature based on eye strain or occupant age, or even your productivity? Maybe it could make subtle changes that we wouldn't even recognize and could judge our productivity based on those. And these are just some things, some ideas that we have discussed internally is where do we go? Where do we stop? Occupancy detection. I mean, obviously we use occupancy sensors and VAVs. We use CO2 to determine number of occupants, but how far can we really go with it? Air quality management, obviously after COVID that or during COVID and after COVID, that is always a big topic for any customer, depending on whether it's in an office or a hospital. Customers are much more likely to spend more now than they ever have been on air quality management. And environmental quality is another way to look at that. Is it just air quality, or are we talking about lighting and noise and all these other things? So as far as the management of that air quality, again, by analyzing sensor data and other sources, we can detect pollutants, adjust ventilation rates, reduce or stop ventilation based on what's in the outside air, and we can optimize our filtration. This helps us to improve occupant health and comfort. If we think about how we treat our air in a building, often we don't really know. I mean, we presume that our equipment is operating the way it's supposed to. We presume that our filters are doing what they're supposed to do based on the inputs that we have and the sensors that we have. Now, one of the underlying goals of this presentation, in my perspective, coming from the technical world as a service tech and a controls technician and commissioning agent, is no matter how advanced we get with the technology that we can see right now, we're never replacing technicians, at least from my perspective. I just don't see how that's possible. The human mind is far more advanced than we give it credit for. I'll touch on that just a little bit here. So as far as AI has transformed the HVAC industry by enabling us to optimize energy consumption, and everybody knows that. I mean, AI, everybody's using AI to a certain degree. What are they using it for? It varies. There's a lot of stuff out there on the interwebs now that is supposedly built by AI, and it's quite convincing. I'd like to think the HVAC side of this is going towards a different goal of making lives better and more efficient. So overall, we're trying to reduce those maintenance costs, and improve that indoor air quality, and be as efficient as possible doing it. By using the machine learning algorithms and other AI techniques, we can achieve optimal comfort levels while minimizing energy consumption. The future of HVAC and AI is bright. It's really exciting, all the things that we've seen coming down, and it's hard to avoid it. It's going to be impressive to see what we see coming next. It's going to continue to be a huge role in what we do. But it's also important to understand we as humans must train the AI and the machine learning based on the outcomes we want. We must be good stewards of these systems and software. And how does AI actually learn? Does it write its own code? Who or what is watching the AI to make sure it's within its purpose towards said outcomes? Is AI watching the AI? Finally, what do we want to get from it? Can we compare the evolution of a slide rule to a calculator? Obviously, we can write out calculations by hand, but why would we do that when we know we can use a calculator? It's way faster and more accurate. It takes that out. It's about precision. Will we reach a plateau of some point? Now, I currently use AI to remove or bypass the noise and syntax of my job. Remedial or repetitive tasks that I would normally spend my time on, I use the AI tools that I have to reduce that. And that way I can spend my time actually analyzing the building and not using my valuable time processing that data. No time spent chasing commas. I mean, think about the evolution from line code to graphical programming. As a technician, I remember many a times sitting on a bucket looking for a comma or parenthesis out of place when I wasn't even thinking about what the code was doing at the time. So that syntax has gone, that syntax issue. And it's kind of the same way if you look at it. So I'm going to leave you with this last thought. The human brain consumes about 10 watts. a typical desktop computer, laptop consumes about 100 watts, give or take. So what does that mean? It means that our brains use less than a light bulb. Maybe we're not the brightest light bulb in the fixture, but it's really interesting to see how we try our best to replace our brains with computers and artificial intelligence, and it is artificial. But what is the end goal? Computers beat humans when it comes to precision and processing speed. But at the same time, humans provide creativity, energy efficiency, and prioritization. So whether if AI fills these gaps, from my perspective, is yet to be determined. Can it sort through the mass noise of the digital world? I mean, it needs that information. Where does it get its information? Obviously, it has the world to look at its information, but it's all about how it interprets it. So, in closing, I really appreciate the opportunity, and this is my perspective in artificial intelligence, and I definitely appreciate the opportunity to share it with you.
Thank you very much, Doug. And we unfortunately are out of time for questions, but I did save a couple that I will get to Doug and get back to the folks who asked them. So we will see everybody in our next session, our panel of AI practitioners. Thanks,
Thanks,
everyone.
Robert.
Thank you, Doug.